Welcome to AD Mathematics, and in this video we are going to look at surd. Now before we understand what surd is, we have to do a very quick revision or a recap. First, we need to know one rational number. What is a rational number? A rational number is a number which can be written in the form a over b, where a is an integer and then b is also an integer. Example, 2, because 2 can be written as 2 over 1. Hence, we say 2 is an integer, which is the numerator, and then 1 is also an integer, which is the denominator. Hence, it is a rational number. Now, what about 7 over 5? Is it a rational number? Yes. This is because 7 is an integer. 5 is also an integer. Hence, 7 over 5 qualifies to be a rational number. Now, let's look at its opposite, irrational number. An irrational number is a number which cannot be written in the form a over b, where a is an integer and b is also an integer. They are numbers like so. For example, when you have the square root of 2, there is no way you could represent this in a form a over b, where you get a to be an integer and then b also to be an integer. Hence, we say it is an irrational number because we cannot represent it in a form a over b. Someone might say, oh, but root of 2 is the same as root of 2 over 1. Yes, you are right to think that way. But let's look at something. 1 is an integer, but root of 2 is not an integer. Hence, we say it is an irrational number. Lastly, before we understand surd, we have to understand what a radical is. When we talk of a radical, we mean the root sign and any expression or number assigned to it. So with radicals, you are going to see roots. It could be square root, quadrant root, whatever root. Okay. Now, let's define surd. This is a surd. A surd is an irrational number written in the radical form. To a more degree of accuracy, a surd is an irrational number which remains in its radical form. The key thing is remains. That means no matter what you do to that particular number, there is no way you could change its radical nature. Example, root of 2, square root of 8, cube root of 7, etc. Okay, so let's move on. Sorry. Okay, when you have, let's take root of 2 for an example. The square root of 2 cannot be represented, I've talked about that one, in the form a over b, hence it is a surd. Okay, so now we say a surd may be written in the form a root b. Remember, I said you could get a surd which is cube root, but under this topic, or because of the scope of our study, we are only focusing on square root. Okay, so always under this topic, for you to identify a surd, always it is written in the form a over b. Now, b, sorry for the interruption. Okay, let's move on. Written in the form a over b. Right, so let's take our first example, the root of 2 that we had. You could say that a is equal to 1, b is equal to 2. Because when you have root of 2, it is the same as 1 root 2. Hence, this is our a, this is our b. Let's look at our third example. Let's look at another example. We have 3 roots, 5, giving us a is equal to 3, b is equal to 5. Now, someone may be interested to know, or someone is asking, what about square root of 4? Is it also a set? The answer is no. This is because the square root of 4 is equal to plus or minus 2. Under this topic, we look at positive roots or positive square root. So we neglect the negative. So the square root of the positive square root of 4 is equal to 2. This is not a set because this one, the root of 4, in its simplest form, it gave us 2. Hence, it doesn't remain in the radical form. Notice the definition. Any number that remains in its radical form. Okay, so once you're able to break it down to get an integer or any other number, an integer, then it is no more a set. Now, notice that we are not saying the square root of 2 does not exist. In fact, it is non-terminating number. When you punch square root of 2 on your calculator, you are getting 1.41421, and it goes on and forth. Hence, we say it is a set. Now, notice something here. We say the square root of all prime numbers is also are also classified as sets. So when you have any prime number, say 7, square root of that is a set. This is because, notice, square root means what number multiply itself to give you that particular number. Very good. And we all know that a prime number is having only 2 factors. Okay, that was just by the way. 2. There are certain things you have to know, especially if you want to understand set. That is the perfect squares. 1 is a perfect square, 4 is a perfect square. I've listed them here, 9, 16. It goes on and forth. This is because when you find the square root of them, you are going to get an integer or a whole, you are going to get, when you find here, you are going to get an integer or a whole number. For instance, square root of 9, positive square root of 9 is equal to 3. Square root of 16 is equal to 4. Okay, I believe you understand up to this point. Now let's move on to reduction of sets. Reduction of sets. I want to keep this video short so that you follow very well. So now before we reduce sets, notice, let's say we have the square root of 24, which is a set. We are still defining set. Why is it that the square root of 24 is a set, but the square root of, let's say, 16 is not a set? Well, to a layman, we could tell that 4 times 4 is equal to 16. Hence, the square root of 16 is a whole number. That means 16, square root of 16 doesn't qualify to be a set. But let's look at square root of 24. Is there any whole number that multiply itself for you to get 24? The answer is no. The answer is no. Hence, 24, root of 24 is a set. Root of 16 is not a set. There are more conditions to it. It will unfold as we move on. Now, when we talk about reduction of sets, we mean reducing the set such that it contains no factors which are perfect. I'm taking it again. Reduction of sets means, reduction to the basic form means writing the set in a form which contains no perfect square. For instance, when we take 24, what are the factors of 24? We have 1, 2, 3, 4, 6, 8, 12, and 24. You ask yourself, are there any perfect, or does the factors of 24 include any perfect square? Yes, 4 is a perfect square. Hence, 24 is not in its basic form. Good. I hope to keep this video short. In the next video, we will take our time to go through the reduction of sets. But before we leave, notice that the number 24 could be written as 6 times 4 or 2 times 12, or 1 times 24, and so on and so forth. So for instance, when we have square root of 24, we could write this one as square root. 24 is a number, right? So you could write it as 6 times 4, because 6 times 4 is 24. So square root of 24 is the same as square root of 6 times 4. Likewise, when you have 30, square root of 30, we could write it as square root of 5 times 6. This is because 5 times 6 is equal to 30. Hence, the left hand side and the right hand side are equal. Okay. In the next video, we'll talk about reduction of surds to its basic form. We'll go into details. If you have any question, do let me know in the comment section. Please don't forget to like, share, and subscribe. See you in the next video. Bye bye.